Okay, hurry. Okay. So the last time we were talking about the first and second derivative test. We were talking about stationary point. How do we calculate the value of stationary point? Okay, so 4.1. Okay, so you remember we looking at the first and second derivative test. Okay, things that you must know that's different from O level. Stationary point basically is a point where, let me just check I'm recording. Okay, good. Basically, it's a case where you have the gradient to be equal to 0. Like this case where you see the gradient is 0. Okay, so what do I call this? It's called a, yeah. What do you call a small size mother? Minimum, correct? Minimum. Okay. What do you call a big size mother? Maximum. Correct. Yeah. Okay. So after that, what do you say? I don't know if I understand. Okay, anyway, maximum basically if I changes from positive to negative. Okay, minimum basically if I changes from negative to positive. Okay, so the idea of turning point is quite easy. So I hope you all can see. Maximum, a point that goes like that. You can see that on this point, the gradient here is positive. Okay, it's positive, 0, negative. But if the minimum is negative, 0, positive. Okay, so far, cannot you get the visual image, right? So what if it's a stationary point inflection? If basically the gradient, basically the stationary point is like a pit stop. So what does it look like? It looks like something like this. Can you see the gradient of both sides? Right? If you see, it stays the same. It's a pit stop. Both sides are more than 0. The gradient does not change sign. Maximum, it will change from positive to negative. Minimum, it change from negative to positive. So far, okay? I know a lot of repeated words, but take it slowly. Now, then I go to 4.3. Okay, 4.3. I don't know why. How come? Oh, sorry. I'm using the wrong class. Okay. I basically duplicate the notes on both sides. Okay. Sorry. Okay. So now, if I look at a local minimum and maximum point, okay, why do I use the word local? If you are the local champion, are you the global champion? So what does it mean by local and global? Local means only for a small neighborhood. In a small neighborhood, this arena, I'm the maximum. Okay, so what do I mean by this? Okay, let's say for example, maximum point. You can see the local maximum could be something like this. This could be my maximum. Okay, this could be my maximum. Example C, FC. But there could be a bigger mountain somewhere. Okay? Yeah, sorry if I speak Chinese. Chinese got a phrase, 一山还有一山高. For every mountain, there's another higher mountain. Okay? So there's a local. So you can see it's a local maximum. It's not a global maximum. So far, okay? Can I? So this definition, see, there's an interval AB. There's an interval AB containing C such that Y is increasing A to C. So you can see A to C, Y is increasing. Xing is that Xing Yu? Xing Yu is sitting there all along. I thought Xing Yu was sitting here. Okay. No. You were not sitting here last time. You were sitting there. Why are you sitting there? Come to the front. I want you to sit here. I want you to sit.不要 sit. How to see you? How to see you? Shift. Fix here. Shift. See, I'm serious. Shift now. If I can shift the letters of the alphabet, I'll put I and U closer together. See. Okay. So A and C, you can see it's increasing. You can see it's going up. Okay. Back to this, dy dx is decreasing. You can see here it is going down. You can see it's going down. A to B is C to B. A to C is going up. C to B is down. This is what I mean by maximum. Okay. So there's a lot of words here, but okay, maybe you're hard for you to understand, but I draw picture, okay? I draw picture, okay, you can see local minimum, interval, a lot of words, very scary, but let me draw the picture for you, very simple. There's an interval. So there's an interval, A to B. Y is decreasing, C is somewhere here, X between A and C, Y is decreasing. Gradient is positive, Y is increasing from C to B, Y is increasing from C to B. That's the minimum point. That's all. Okay, can I? Will it kill you if you don't understand all this? It won't, it won't. Okay, but you understand that the words, okay, the words tell you a picture. Okay, basically, minimum must be gradient negative, gradient positive. Maximum must be gradient positive, gradient negative. So far, okay? Can I? Okay, so then with that, you take a look at question 4.1. Question 4.1. Are you all doing it again? May you slowly do 4.1. I think very easy for you. Okay. Wow. Are you in question again? Wait. Then who was sitting there? Oh, so kind. Then who was sitting? Who was sitting there? Huh? Oh, then okay, we did. Okay. Baba is sick. Baba is sick. Okay, one, two, basically you have to differentiate and then you have to equate to zero. You have to equate, okay? Because you need to find the coordinates of the turning point. So fast. Okay. 4.1, if you are there at part 3, you will realize that they are asking you to do something called the first derivative test. As you go to part 3, I will talk about it in a while. Okay, let me just write it out. The answer A should be 5, B should be -9. The coordinates should be 1, 0, 3, 0, and 9/5, -3, 4, 5, 6 over 3, 1, 2, 5. Okay. Bottom. Okay, so some of you are already done. Very good. After that, for part 3, okay, you realize that, sorry, this one is wrong. -3, 4, 5, 6, 3, 1, 2, 5. This is -3, 4, 5, 6, 3, 1, 2, 5. Okay, you know there's a typo on bottom of page 18. I believe so. I believe. I'll go. There's a here. Can try to be to 0 and there's a product. Everything is equal to 0. Oh, part 2, you need go on to find Is it recording? Yeah, I hope it's recording well. I go a bit to the left. I find the gradient as well. Okay. After that, I found that since this is positive, right? This is 0, this is negative. I conclude that it is a local maximum point. Include the word local. Okay. So what is the idea of Sadhana, Archie? The idea is that the turning point without. Okay. Ah. Yes, you draw the box. Ideally, if you can draw a 3x4 box. This is only 2x4. So ideally, yeah, draw a 3x4 box. What do I mean? Is I draw 3x4. 3x4, 1, 2, 3. So this is 1.1. Negative 1.2635 less than 0. You can write down the tangent. So that's how do this like that. I'll draw another 1.98451. 0.9 6x is dy dx. Remember for dy dx, write down the number and the sign. And don't just write number, don't just write sign. Write the number and the sign. Three by four. Oh yes, so you value 3 table. By right. By left is okay, later on you can use second derivative test. I can use second derivative test. But second derivative test does not work all the time. There are times where your second derivative test it does not serve you well. It doesn't give you the nature. If your second derivative is equal to 0, then basically you cannot conclude. Sorry. Yeah. Why you fast?
Let's draw like that. Is it done? You
What?
must draw it.
Yes, try to draw a 3x4 table. Where's your okay. Wow, very messy. So you sub 2 to you sub negative.
Okay.
Okay, so this one. Okay. Okay. Okay, you. What's for you? Oh, here, Ooh, slow. Yeah, so if you are using derivative 2x4. Oh, so like for example, 3, 0, you realize that it's the same. It is a point of inflection. Okay, it is a point of inflection. Okay, okay, let me slowly write the answer down. Okay, you don't need your iPad, so please keep your iPads. Please keep your iPads. You all don't need your iPads. Keep your... You all hear me? I say keep your iPad. I'll ask one more time. You all still put on table, I confiscate. Okay. Yeah, can. Face up is okay. Oh, so many. Oh my God. Yeah, can. No, right. Okay. Tiêu in to find okay, 4.2. After you substitute, the y value must be here. These two are your y values. Okay. So you submit already, right? These two are your y values. Value 1, value 2. Okay. Okay. After we go into you draw a 2x4 table. 2x4 means 2 rows, 4 columns. So far, okay? Now with this table, right? Okay, if you are at so be a pi of the value is a I suppose if I put big, I mean engulf another 30 points. So for example, if my graph, right? Let's say my graph is like this. And then I choose this interval. Let's say it's like this, right? I'm going to choose this interval like this, right? Then my conclusion will be wrong. So that's why I must always choose a very small interval. Okay? Can I? How? Why the heck so long? Remember, e power negative x will never be 0. Remember if you do quick. Okay, so far so good. 4.2. Most of you are at 4.2 already. 4.1 okay, can you just check? So I say again, if you are at 4.1, make sure that you have done the table. First derivative test must show table. Okay, now, okay, when you are writing this, you need to write down what is the local maximum and local minimum. Okay, okay, those who go tuition, for example, your tuition teacher will tell you maximum. But please take note, NJC, please take note, NJC local maximum. Okay? And, huh? Which one? Oh, should have. Yeah. Why? Because O-level context, they just consider the stricter definition is local max, local mean. Okay? Can So please take note, you need to write this in. Okay, Can Okay. Now, let's go to 4.2. So that's what we call the first derivative test. First derivative test, you draw a 2 or 3x4 table. 3 rows, 4 columns. Okay, make sure that you are able to always show the table correctly. Okay, now if I bring your attention to question, can you just pause for a while? Look at the screen. Okay, can everybody be like copy what he sees on the screen? Okay. Okay. But when you choose points, let's say, for example, it's most important is sum the grade. They were, yeah, so I walk around. I walk around. Do you mean that it wasn't recording just now? Oh no, I'm so sad. When did it stop, man? Okay. Next time, I follow Dr. Low by the. Yeah. So, okay. So remember, when you are doing first derivative test, use a small neighborhood. Don't use too big. Okay, look at me. Because when your okay, so I always as a precaution, look at me. I always use plus minus 0.1. Okay, because if your neighborhood is too big, you may engulf other turning points or stationary points. Then your conclusion will be different. So for example, if your graph looks like that, and the interval you use to be, and the interval is coming soon. So let's say for example, the interval you use is here and here. Correct? Then you that both are telling you there is an inflection point. But is it true? It is not. Because your interval is too big. Okay? So as a guideline, your interval is always plus minus 0.1. Clear so far? Reason because if your interval is too big, it will engulf, it may engulf means to eat up. It may engulf other turning points. Clear so far? Okay, I'm going to ask someone to repeat what I said. Sean, why is it when you do first derivative test, must the interval be small or big? Why must it be small? Very good. Let me ask someone else. Choose another person who you think will benefit from me asking the question. Joshua. No, it's okay. I'll ask someone else. Jialin. Okay. Can I ask you why is it the interval must be small or big? Why must it be small? So I don't eat up other turning points. Okay? Can I? Okay. Now next. 4.2. How about on the oh, no, yours is better. Yours is better. Yours is better. Because mine I didn't rationalize denominator. Yeah. Yours is better. Yours is better. Yeah. So this is the same as square root 2. Okay. Okay. So basically, even though the question did not ask for exact coordinates, you can just challenge yourself to have exact coordinates. Okay. Okay. You are right. You are right. Thanks for highlighting. Remember to draw table if you're using the first. So it's safe, okay? Okay, Alex, very nice. Your one. Okay. So if you are at 4.2, okay, what you're going to do? Differentiate first, equate to 0. Why is it? 5 days. Okay. So second derivative, you're there again, no, you're second derivative test I will use when, for example, if it's very easy to differentiate second time. Example like some polynomial, simplistic polynomial, I will just differentiate second time. But there are times where the second derivative test will fail. Yes. That's why I will use. If it's second derivative gives you 0, then inconclusive, then I must use first derivative test. Okay? 可以吗? Can I? But if you are at 4.2, I think you are not there yet. That's a what? Yes, it's easier lah. Correct. When do I use first derivative? Basically, first derivative works 100% of the time. Okay, okay? You do wrongly? Never mind.
No, I go use this one instead of this.
Okay. You must sub into this one. Okay, your coordinates are nice. Okay. Then after that you equate to 0. Okay, Aidan, I help you a bit. So no need to do factor theorem. Just play cheat a bit. Okay. These two x, these two, good. Then you can see both have x plus 1. And then factorize are x plus 1. Okay. See, 4.28. Yeah. The focus is not on factorizing, not just to allow you to get your calculator. Don't tell me. Yeah. Don't tell the assembly. But try to factorize. You can do grouping. Grouping will allow you to find the exponent. Come in? I'm discussing with them because if I give you, I have to give everyone. Oh. Yeah, we have to give the whole ball. We cannot just give one person. So it has to be. It has to be fair, lah. It has to be fair. All the questions we discuss, we discuss. Try to write dy dx. Y prime not so common. I try to write dy dx more. Yeah. Y prime you can use if the question start using first. Yeah. As long as y is defined, you use y prime, it is not wrong. Okay, it's not wrong. Okay, very good. You got pi over 4. Then remember to do the first derivative test for pi over 4. Pi over 4 is about 0.75 at plus minus 1. Yeah. Hey, draw table, use ruler, please. So basically, okay, because you are in degree mode, so you divide by pi, the answer is 1/4. 0.785 is about 1/4 pi. Okay, so you just think it's about 1/4 pi. Okay, can solve. You should get your alpha to be pi over 4. But what is x? X should either be pi over 4 in the first quadrant, or it could be plus pi, right? Then I realized that cannot, it's not the range, right now. So what must I do? Pi. So the answer that you are actually using is negative 3 pi over 4. Okay. If your answer fall in the range, remember BQRA, R is for the answer doesn't fall in the range, make sure you use the go back minus 2 pi. Yes. How do I get pi over 4? Because you get sine x equals to cos x. ORG. Over here, you get something like this, e minus x. I think you get something like, is it cos x minus sine x equals 0? Then this part can never be 0. This one is rejected. Tan x equals to 1. Right not? It's equals to 1. You divide, it's equals to 1, not 0. Clear so far? Just now I was doing okay, this one's 1. Okay, right. Because so we don't usually use cotangent, we use tangent. So I solve 1 same. And very quickly, you can get a basic angle. That's what it's just 45 degrees. a lot of our, which is pretty good, doing very well. It can't be so fast. Wow, tuition. No, do yourself. Done. Very good. Good job. Hey, why are you so smelly? You smell like Zhe Kai. Huh? No, never. So 16 years old already. 16 years old. You use, okay. Okay, so what you must show? You must show number, you must show sign. There is a good sign. Okay, very good. So after that, you write down. Okay, it's good. So after that, you look at the question 4.2. 4.2. What was that question? 4.2, right? The question was 4.2. Okay. 4.2, in case some of you all have an issue, you reach this point, cosine x equals to sine x. Okay, common mistake is over here, right? People divide. Okay, you must know that from here, you can even use R formula, but okay, anyway, from here, you divide by cosine. The right hand side is 1, it is not 0. Hello. Okay, so the right hand side is not 0. The right hand side is not 0. The right hand side is equals to 1. Okay? Can So when it equals to 1, 1 is a special angle, tangent inverse 1 is pi over 4. After that, still not done. Now, if you got two answers, okay, you realize that because the nature of the quadrant, the nature of the range is between negative pi to pi. Right? So it's a trick, it's not easy. So from here, get tangent x equals to 1. Your alpha is pi over 4. Naturally, your x is, you're going to write down quadrant 1 and quadrant 3 answer. Okay? But this will make you reject your second guy because he is out of range. So when somebody is out of range, what do? Somebody is out of range, what do? Anyone can tell me. If this is out of range, what do? You got a second guy, but he's out. Huh? What happens if you lose your wallet? You will go backwards. If I trace your steps, minus 2 pi. So the answer is negative 3 pi over. If I minus pi, then this is answer. Yeah, so I'm minus 2 pi. Yeah, because I'm teaching them just finding quadrant 1 point without approving. So of course, if you are fast, you can straight write down the answer. You need to go to? Sure. Charge. Okay. There got charger? Don't have. Okay. Maybe you just use pen and paper. That will work better. Okay. Okay. So next one. Who is at 4.3 already? If you are at question 4.3, 4.3 focuses on the second derivative test. Now, do you remember that day I explained the second derivative test? Do you still remember how it works? Xing Yu, you want me to explain again? Okay, so maybe, Xing Yu, let me explain to you. Okay. Okay, so Xing Yu, let me give you a graph. let me give you a graph. Okay, let's say I put it as y against x. Okay. Now, see, I draw the graph out. It looks like this. Okay. Can you tell me? Over here at this point, what would the gradient be? At this point, what would the gradient be? Give me a guess about the value of the gradient. Huh? What's the guess? Where? Negative? What's the guess? I drop something. Who's gigantic fruit basket? Alexis. Okay. Send already. Okay. Okay, can So, sorry. Where am I? See, back to you. Stop touching Alex. What? Huh? What's wrong with that? Okay. So, Xingyu, wait. Listen. What value is this? Those who want to get a recap or teaching or second derivative, please tune in. Okay. What's the gradient here? Negative 10. Very good. What about the gradient here? Negative 7. What about the gradient here? Negative 5. Very good. What about the gradient here, Sean? Negative 3. What about the gradient here? Negative 1. Hashini, what about the gradient here? If we are doing something else, sorry. 0. Very good. Who is listening to me? Sadhana, what about the value here? What about the gradient here? 1. Very good. Kaisen, what about the gradient here? 3. Salihan, what's the gradient here? What's the gradient here, Micah? 7. Thank you. Okay. What about the gradient here? Dora? 10. Very good. Now, you all look at the gradient, right? Okay. I use the gradient. I draw the gradient versus x. Can you see? Look at this number. Negative 5, negative 3, negative 1, 0, 1, 3, 5, 7, 10. Look from left to right. What's the gradient doing? Is it getting bigger or getting smaller? It's getting bigger. So now, you see, let's say I draw gradient versus x. The gradient is negative 10, negative 7, negative 5, negative 3. The gradient is negative 1. The gradient is 0. The gradient is 1, 3, 5, 7, 10. Look at this. What kind of line do you see? Okay, now I use inception. If this is gradient, right? It's something like dy dx, right? Correct now. Inception. What is the gradient of this gradient? Am I right to say this d2y dx squared is the gradient? And is it positive or negative? Positive. That's why you can see when it's a minimum point, it is positive. Okay? So that in essence concludes the derivative test. Okay, then why are you smiling? Because what? Dora, what happened? Is it because nobody responded to me? Then what happened? Huh? Yeah. Stop smiling when I'm. Okay. Okay, so collateral damage. Yeah, it's collateral damage. Can understand? Okay, so after that, so you can see the other way around. So gradient, second derivative positive means minimum. Second derivative negative means maximum. Okay. So with that, I bring you to result 4.5. If the second derivative is positive, second derivative negative is maximum. Okay, I hope I explained it to your understanding. If not, let me know. I can go through again. Okay, generally, second derivative is preferred for me. If once it's convenient, it's easy. It's like the 7-Eleven. It's downstairs your house. But if you want to do first derivative, You must go NTUC or Giant or Sheng Siong. They have everything. Okay? Huh? Pay attention, please don't talk about other things. Okay, yes. Huh? 4.2b. Go through. So next, I go through 4.2b. 4.2b, you take this, you differentiate. Okay, so as I differentiate, product rule. Product rule. Is it okay? This part. Can I differentiate? Now, because we are finding stationary point, we equate dy dx to 0. Okay? Now, when I equate dy dx to 0, then I get tangent x equals to 1. Okay? Now, when I equate dy to 0, okay, so this is, I'm equating this to 0, right? Can how? Oh, sorry, wait. Sorry, I show you. Okay, see, I take e power x cosine x minus sine x equals 0. Is it okay? This can be e power negative x equals 0 or cos x minus sine x equals 0. Is it okay? Then this one basically reject because e power negative x will never be 0. Okay? So this I will have cos x equals to sine x, right? Which is the same as sine x over cos x equals to 1. T, which is the same as tangent x equals to 1. How do I get from here to here? I divide by cos x on both sides. Divide by cosine x. Divide. How does it show? Okay, divide. Yeah. Then does it? Then I do then b. So then, from here, alpha is tangent inverse 1. Hello. No, I'm shooting at dollar. Sorry, I'm shooting at dollar. 5/4. Okay. Then after that, there can be two answers. Okay. The answers x can be pi/4 or negative 3 pi/4. Then you find do your first derivative test. Okay. Yeah. For this one. Okay. Pi/4, you substitute. Okay, the numerical value is about 0.785 to 368. Is that okay? It's about 0.78. So of course, before you first of all, successfully get these two. After you got these two, you find the 1.8. Because the question asks for coordinate lah. Yeah. Okay, if it's 3SF, it is all right. Okay, because the question did not ask for exact. But if Archie, I can challenge you, just try for 3SF. Just try to find exact. You never know. Sometimes the question requires you to be exact. Or after that, once again, okay, after that, actually you see, pi/4 is 0.785, right? I go to a small neighborhood plus 0.1 minus 0.1. Remember, it must be a small neighborhood. Don't be too generous, be stingy. 0.785 plus minus 0.1, substitute the device and check value of device. Remember, write the number, write the sign. Write number, write the sign. See what I say? Write the number, write the sign. Write the number, write the sign. They will tell you whether it's a positive or it's a maximum or minimum. Yes. And just write pi/4 minus 0.1. I get what you mean, but try to find the actual value. Try to find the actual value. Oh, yeah. You got 1 and 4. Let's see. Yeah. Question 4. You set with test. Okay. You got x2 is equal. So do what as well. So after that, your x, yeah, because once 1, right, your ln x is not 0. Your ln x is negative. So you will make a small difference. Okay? And uh, 6. Every turning point that you find, 4.3 onwards, then you practice. Okay, so you are at 4.4. Very good. Okay. You don't see those. Table here. Table B. For this one. For yes. So no. No, you don't equate the second derivative to 0. What you do is, okay, you equate to 0 first. Equate it to 0 first. So to the second derivative. Okay, I'm sure. Question 4.3, right? 4.3, yeah, show you. Okay. 4.3. Six x squared minus 18x plus 12. Now, remember to find stationary point, we are equating dy dx to 0. Correct? So this 0 equals to 6x squared minus 18x plus 12. Now, okay, then I won't show you the whole process. I think it will bore you. I'm going to tell you straight away. My answer is x equal 1, x equal 2. Okay? And then reduce, you sub in. So you sub x equals to 1. What's your second derivative? Your second derivative is 12, 1 minus 18, negative 6. Sub x equals to 2. Second derivative is, I think, 6. Equals to 6. So if the second derivative is negative, it tells you that x equals to 1 gives you a maximum, local max. If it's positive, x equals to 2 give you a local minimum. Is it okay? Can I? So the conclusion is from result 4.5. When it is a second derivative, subbing in the value. This one means I sub in. If it's more than 0, local minimum. Sub in. If it's less than 0, it's a maximum. You understand why? Sort of. I should, like you saw when I was explaining to them just now. Okay, if you don't know, you tell me. I explain again. Emily, yes. Sorry, Emily. It's local, I think. 7. Ah. We check. First of all, the curve is continuous. If it's continuous, right, we just see that. We try to prove like, for a certain domain, it's always. Okay, the rest in fine, you don't do it here. Check. Hey, okay, make sure you find the numerical value. Okay, wherever you are. Okay. Number and this can for me just no, try to close. Differentiate this one. Differentiate log x is 1 over x. So it's 2x times 1 over x. Oh, sorry, x squared times 1 over x. My bad. Come again? Yes. No. You sub back to find the y value. So you must always know who you are subbing to and what is it to find. See you are finding. If I sub in here is to find y value. If I sub in here, I'll get 0. If I sub in here is to check nature. Okay. Every derivative cause sine is okay, doing well. Very good. 1 second. Okay, huh? Why? So is that yours? No, Colin's one, huh? It's yours, huh? Okay, so if I look at the curve, okay, this is this is your dy dx. Which one? Emily, you gotten this right. Then you see this is always positive. This is always positive. Right? This one depends. It depends, right? So if x is less than 1, I mean, if you solve the inequality, you know that there are two possibilities, right? Where can be positive. I mean, like more than 1 than kx, x will be than 1 over k. I got this one. So then just take the complement you get. Yeah. So that's okay. You see, I is increasing from negative infinity to negative 1 over k and decreasing 1 over k to infinity. Right? So if I'm able to show that, I'm also show you a picture. The picture is like this. That means my graph is going all the way up from negative infinity to 1 over k. And it's going all the way down from 1 over k to infinity. This is telling you that, I'm in no man's land. To my left, I see no one. To my right, I see no one. Because I'm always going down and going. That concludes that it is a global maximum or global maximum. Is it okay? Can yeah. Not easy to a lot of times it's just about writing. So they are testing whether when you write, you understand the concept behind the local and global. How do you know whether to use okay, so maybe you differentiate one time first. Differentiate one time first. Then you see. Let's see. Are there times where second derivative test fails? Yes. Okay, can are you able to get function that works like that? Wow, you're really a genius. Okay. Yeah. Okay, example, Alex, are you able to give me a example by second derivative? You try. Try. Don't, I don't do too difficult. I don't do y equals to x has no turning point, man. Something where the second derivative is 0. So wrong. Huh? 4.5? 4.5 is a horizontal line. But there's no turning point. Example, something that gives you second derivative 0, but it's actually a maximum minimum point. Example of an equation. Quadratic. Possible. But I want to sub in. Possible. I think quadratic is correct. Oh, not plus x. Y equals to x squared. Y equals x squared is correct. So a safer one, maybe you can use y equals to x power 4. Y equals to x power 4. You can see, the graph has a turning point. Y equals to x power 4. The turning point is 0, 0. Oh, so now then you realize, this one got come out before. Previous years we test out. Yeah, lor. Okay, so then you see that dy dx, right, is 4x power 3. But what is d2y dx squared? What happens if you sub 0 in? And x equals to 0, d2y dx squared is equal to 12 0 squared, which is 0. But clearly you can see that second derivative is 0, but it is a minimum point. These are times, this is an example of a case where second derivative test fails. This one came out before. Previous. Why you can copy that? Yes, x also can. Yes. No, okay, so like analogy okay. For example, Sean wants to buy a highlighter. He wants to buy a highlighter. He runs to the 7-Eleven store trying to find one. Some days he's lucky, he got one. Some days the shop doesn't sell. So he has to run to the popular bookshop to get it. That's it. So it's just a don't think of it as two weapons. Yes. If second cannot. So if your second derivative is 0, right, it is inconclusive. Basically, it's inconclusive. So second derivative is a point in time where you will fail. Where is it? That is inconclusive. It may be 0. Right. But when you get 0, it doesn't mean that it's a point infection. So like I was saying, like I was sharing just now, right? An example again I show you is y equals to x power 4. Yes, a lot of people, they make the mistake when second derivative is 0, they go and say it's a point inflection, which is wrong. Like you can see in this case, when it's 0, right, it's not inflection. Inflection can only be proven by first derivative test. Okay? I must remember to write stationary point of inflection. Who's pencil? Yeah, Ah,
So how do I know? So I got this. Oh my god, this is then how do I know? How do I know? Once I got the derivative, I got the first derivative. Then how do I know first or second derivative?
okay, so
use the suitable one.
use a suitable. Usually, I will see what is the function. Okay, so like this function, I can see that it is quite easy to differentiate. So if it's easy to differentiate, what I'll do is I'll just try do a second time. If it's because it's
fine.
so I see hey bro wrong. First of all, this one is not dx dy dx is a noun. Ddx is a verb. That dy is an action. Dy dx is differentiating this. Differentiating this. Second of all, why wrong? You never use product rule. X, X not one. Yeah, finish product rule. Here is one, here is one. First, and that is too much for you, you can use first derivative. That's all. When it's easy to differentiate a second time, then I will use yeah. Why when you go to first derivative, so inconclusive. Remember I got say if the second derivative you can zero mess up already. That means I have to go back to first. So just it's not necessary. You have two iPads. Okay, no problem. Berak. Okay.